which is certainly an option for you guys at some point. This is about 1 to 2% of what you would see in AP Stats. So my point, well, we're spending a week and a half on it. They spend an entire year on it, so it makes sense that it would only be 1 to 2%, right? But we'll see. You get to see if you have a general like for it or a general dislike for it or whatever. Anyway, we'll talk more about that as we go on. I am not going to be here Thursday, by the way, just to give you a heads up. Save the cheering a little bit. Hi, G. It's great to see you again. Now get out. See, he's trouble. That's why I kicked him out. So anyway, just as a heads up, but luckily I have everything printed and everything like that, so that won't be a problem. Don't know who the sub is. It's not a name I recognize, but some sub already picked it up. And I think it's a she. I'm sure she'll be very pleased when she gets to 7th hour after having gone through 3rd and 5th, and then she'll get to come in here and have a good end to her day. So, ready, Christian?
I am.
Cool. All right, statistics. Here we are starting today. The title is Shape, Center, and Spread. Distribution, shape, center, and spread. To begin with, this is what we call a normal curve. This is a normal curve. You may have seen one of those before and referred to it as a different name. Have you ever seen that? It's a different name before?
Yeah.
Instead of a normal curve? Bell curve, yeah. This is the same as a bell curve. A lot in the middle, lower as you go further away from the center. We were thinking about grading in this course on a normal curve. What do you think about that? Good idea or bad idea? Bell curve, grade on a bell curve. Way better?
I mean, at least for, because I'm taking on bell curve.
You just said that
Do the same thing. Oh, my bad. Wait.
Bell curve and normal curve are the same thing. But my question is, would you rather that we graded on a bell curve or the way that we're doing it at this point? Okay. Well, tell me about if we graded it this way. Most of the grades would be in the center. What's the center of grades? What's the middle grade? The C. Right? You have A, B, C, D, F, right? So the middle grade would be a C. So you like that idea?
Well, actually, yeah, I do.
You do?
Why? Because if I
On a bell curve, you would have as many A's as F's. How do you feel about that? Think that would work in here well? No? You think I'd lose my job pretty quickly if we did that? AP exams, SATs, are all graded on normal curves. I'm just going to stop using the phrase bell curve because here we're going to call it normal curve. SATs, AP exams, etc. are all graded on the normal curve. On the SATs, the middle score is a 500. And then the standard deviation, which we're going to talk about in a minute, is 100. The lowest that you can get on an SAT is 200 up to 800. So there should be, if the normal curve is done correctly, as many 800s as there are 200s. I can't remember ever seeing a 200. And I have seen many 800s, but I think that's just the students that I've taught. So lucky there, but I've never seen a 200. I've seen upper 200s, but I've never seen a 200 itself. That'd be crazy. Anyway, the reason that SATs and AP exams and stuff like that are graded on a normal curve is because it's a different test every year. Makes sense there? Like they can't give the same SAT in March that they're going to give in because cheating. But what about the person who takes it in March and in May? That'd be pretty cool if you went in to take the SAT and it was the same SAT that you had previously taken, right? So that's why they change the test all the time. So the only way that they can be fair is to curve it. Okay, they try to make the test as good as they can, but they're never going to be the same. So what they do is they say, all right, the mean score, the average score will be a 500. We'll set the standard deviation and be 100 and stuff like that, and they're able to crank that out that way. We don't grade that way, obviously, but we will use this for many other things, as you're going to see.
Why don't?
Because if we did, then there would be more C's than anything else, and there would be as many A's as there are F's, which in a class like this would probably not be appreciated very much. Sometimes it doesn't look like a normal curve. The distribution looks more off balance. That is called skew. Okay? Now, this one looks like it is skewed to the, does it look like it's skewed to the left? Is that what you would say here?
No.
You would have said to the right, right? And that's what I would have said too, but it's not. This is called skewed to the left, so it absolutely goes opposite what you would expect. This is called skewed to the left, this is called skewed to the right. Okay? I can't tell you the reason why. You just have to remember it and deal with it. I will. I'll get there. Okay. The center. There are different measures of center, and you have dealt with them all. You've seen them all before. They call it here a balance point. It's the point in the graphic display where about half the observations are on either side. Okay. Mean, median, and mode are your three main measures of center. What is mean? Everybody says average. Average isn't a fair way of putting it because all three of those could be called the average. So how would you calculate mean?
All numbers added up, divided by the number of numbers.
Add up all the numbers divided by the number of numbers, or the number of data points. What about median?
The middle number.
The middle number. If
There is
the numbers
are
are what? In order. Do they have to be in order?
yes.
Absolutely have to be in order. Because if they're not, the middle number could be the highest number, or it could be the lowest number. It wouldn't be fair. Do they need to be lowest to highest, or highest to lowest? And the answer is it doesn't matter. It makes no difference whatsoever. As long as they're one order or the other, we are okay. Okay. By the way, in this unit, a lot of what you are going to do, remember how throughout the year I've gotten a little grumpy when you give me like one-word answers and stuff like that? Like if I say, what's the mean, and you go, average. I'm going to kind of push you for a little bit more. In this unit, it's not, I'm hoping that you'll give me a little bit more. It'll be required. In fact, a lot of your answers will depend on your explanations of how you got them. Okay? So make sure that, as you're going on here, when it says things like explain why, then make sure your explanation is significant and useful, and okay? Not just one or two words or something like that. All right? The third measure of center is mode. Anybody remember mode? It's the number that the data that occurs most often. Mode is typically not a very good measure of center for a class of 25 people. It is a much better measure of center for a census, for instance. Anybody know has anybody heard of the census?
Yes.
What is the census?
Every decade, the U.S. government just collects information or statistics on the population.
Perfect. Yep. Every decade. The last one was in 2010, so the next one's coming. 2020. It is a pain in the neck, by the way. It is like 15 pages long. You are required by law to fill it out. They want to know, they will send it to every household, and they will ask pretty much 1 million questions about each person in the household. Age, gender, race, married or unmarried, job or no job, just all kinds of different things. And because they want to find out how many people live in the United States, how many people live in Arizona, how many people live in Phoenix, how many people how many children are there, how many elderly are there, how many of each race are there, etc. It's all just counting. And what will happen is, depending on the numbers that they come up with, they will adjust some things. Our government is based on the results of the census. If in the last 10 years, Arizona got a lot more people and Illinois had a lot of people move out, well, Illinois might lose some seats in the House of Representatives and Arizona might gain some seats in the House of Representatives. And it's all based on the census. So the census will be done throughout 2020. Probably by about 2022, they'll start making adjustments in there. That'll also have to do with what happens in the state House of Representatives and things like that. So they'll count the number of kids. They'll try to figure out what the average age and stuff like that is going to be, and all that stuff. So the census talks about, one of the questions that will be asked is, how many children are there in the household? So how would you feel about being the person that they say, okay, calculate the average?
No.
Why not?
I mean, there's currently 7
How many
billion
people are in the country?
world.
Anybody know?
365.
Little, is it that high now? Thought it was about 330. 365, really? Wow.
Yeah, it's somewhere around.
365 million people, so
That's
So-
too many.
you're going to have to go tens or maybe 100 million households and count how many kids are in each family. So how do you feel about doing the mean for that?
I'm straight.
Not real good? What about the median?
I mean, unless you like writing out
I mean, I'm
365 million numbers.
Median road would be as hard as.
Do you feel like writing out every number and then counting down from 300 million
Did you
to
put it in
get
a
to the center?
computer? Is there a computer program?
10 years ago it was paper. I expect that it will be paper. They try to figure out homeless too, which is always an interesting one because you can't send the census to a household if
If you don't have a house.
there is no house. But they do what they can there. So my point is that in something like the number of children in a household, mode is going to be your way of working that. That'll be the best measure of center because it'll be the easiest to calculate. If you have 300 million, you just pick the one that occurs most often. What would you guess would be the mode for the number of children per household in the
3
US?
to 4.
It's actually 2. The average American family last year is 2.5.
Wait.
It was, they took the mean and they said it was 2.5.
Right, and I asked you what the mode was,
I
and you
was
told me
saying
2.5.
I have 2.5 kids.
I was saying it's 2.
What's the mode? 2.5.
My favorite kid's my half kid.
I know, because it's half less annoying.
Right.
Challenge.
2 has been the mode for many, many years in the US. He said 2.5.
I have a friend who has 8
You're looking at me and
siblings.
saying,
Is it 2.5?
all right, so mean, median, and mode. Now we talk about spread. Okay? The spread, please. Spread refers to the variability of the data. If the observations cover a wide range, the spread is larger. If the observations are clustered, the spread is smaller. Okay? So, it's like on a test. If, there are many different ways for the average to be 83%. We could have every single person in the class get 83%. We could have almost everybody get hundreds and like 2 people get like 5s. But these are possible, right? Spread tells us a little bit more because the bigger the spread, the more spread out the data is, the more clustered, then the measure will be smaller. So the three that we will talk about are range, which you know about. Range is, how do you calculate range? Highest minus the lowest, okay? Standard deviation we're about to work on, and interquartile range we'll work on tomorrow, okay? So, but these make it a little more interesting. You know, it's, anybody can find the mean. Anybody will be able to find the standard deviation, but how you apply the standard deviation makes things a little more interesting for you.
We don't do that. I mean, the meaning absolute, do that. The mean absolute deviation.
Absolute deviation.
Okay. The man. We don't do that.
I don't even know what that is.
What?
You don't know what that is?
Never heard of it.
I deserve your job.
Oh.
It's probably, my guess would be it's standard deviation,
Yeah, it's
But-
probably is.
but I've never heard it
But it's
referred
like
to that
a
way.
big range.
So, here we go. If you do not have a calculator, you are going to want to have a graphic calculator. So, get some out. And by the way, can you guys help me out at the end of class, when you put them away, can you please put them away better than the other classes have, where it's just a disaster in there? I would appreciate it.
This is gonna be really interesting.
Okay.
Oh no, did you hear,
Ready?
did you see the whole conversation I had with
Do
her?
it.
In order to like, get to what we want, the athletic director, we need to cooperate and change. Otherwise, she's gonna have information that says, we're not cooperating, and I don't think we're gonna be able to do that. And also, I don't even think they can pay for having it.
Do me a favor also, if there are battery issues with the calculator, please don't just put it back in there, because I don't know which ones to change the batteries of. So if there's one with a battery problem, another one. Does it say something or it just doesn't turn on? That looks fine. This should work during class, but give it to me at the end of class, okay? Those should be okay for now. Usually, when it says your batteries are low, recommend to change, they're usually good for a week or two.
Oh, yeah.
When it's like low charge, it's good for a month.
All right, so, I need to pick up the pace here, so I need less chatting and more on math, okay? All right, 5 people were asked approximately how many hours of TV they watch per week. Their responses were as follows: 6, 4, 6, 7, 8. Find the mean number of hours of TV watched for those 5 people. Go.
Yeah, very okay.
I remember learning I know, my brain didn't work like that.
Okay, we get
It
number?
really goes a long time ago for you. It was a long time ago for me. It was 6 years ago. That's terrifying.
I'm hearing 6.2. Do you agree with that?
Yes.
Okay. All right. So now, oh God, please, you guys are driving me nuts today. All right. Find the deviations from the mean for these 5 data values. Record your answers in a table. So what we're asking is, take the actual number of hours and subtract the mean. All right. So 6, what would be the deviation? No? Negative 0.2. 6 minus 6.2 is going to be negative 0.2. What about 4?
Negative 2.2.
Negative 2.2. 6 is another negative 0.2. 7, 0.8. And 8, 1.8. If we add up all of these deviations, what do you think we should get?
0.
0. Why 0?
Because they're all from the means.
They're all from the mean. So basically, when we add up away from the mean, we got 2.6 negatives and we got 2.6 positives, which actually makes sense. If we're talking about how far from the mean, when we add up all the negatives and the positives, we should get 0. Does that make any sense? So that, check it if you want that way, not a big deal. But that's part B. So we did that. Part C says square each of these deviations. We're going to put that over here. So if we square negative 0.2, what do we get?
0.04.
0.04. Positive or negative?
Positive.
2.2 squared?
4.84.
4.84. Negative 0.2 squared again? 0.8 squared?
6.4.
0.64. And 1.8 squared?
3.24.
3.24. That's part C, square each of the deviations. Now, what we're going to do next is in parts D and E, we are going to basically find the average of the squared deviations. So, therefore, the mean of the squared deviations, which means that we are going to add them up and divide by the number of numbers, which in this case is 5. So, let's add them up. 0, carry a 2, 10, 18, carry a 1, 8. So I'm seeing 8.80 as the sum of the squared deviations. Agree? Which means that over here, 8.80 goes down there. And we divide by 5,
1.76.
which gives us 1.76. So the mean of the squared deviations is 1.76. We now are going to take the square root of that. Part F, we take the square root of 1.76, which gives us 1.327. Is that how I remember it?
Yeah.
1.327. This is the standard deviation. Okay? What does this stuff mean? Well, it says describe what the mean and standard deviation represent in the context of the data. So let's talk about the mean first. What does that represent?
The sum, or the
You could say average.
Average of all the numbers.
The average number of hours of TV watched by these 5 people. I would agree. Now, standard deviation is basically what the phrase says. Standard, meaning kind of average, deviation, distance from the mean. So standard deviation basically means the average distance from the mean is about 1.327. So in the context of this problem, these 5 people watch an average of 6.2 hours of television a week. And the average deviation from that is 1.327. Okay? It's the average distance from the mean. How do you feel about calculating standard deviation?
Okay.
What do you mean, big numbers?
Like bigger amounts of data.
More data. Yeah. So how would you feel about getting standard deviation with a set of like 20 numbers? It would take a while. Because, I mean, we did 5 numbers here, and we had 6 steps, and we had to do with 5 numbers. 20 numbers, even 10 numbers would be a pain. And that's why, in the year 2019, we can ask for help from our calculator. And that's what we're going to do next. In our next set of data, the amount of time in minutes spent studying for a math test by 10 students, we're going to teach our calculator how to do this. Well, our calculator actually already knows. All we have to do is give our calculator the data. That sounds familiar. It sounds like we've done something like that before. Well, the directions are here in terms of how to do it. So let's get started. Step 1, stat.
Edit.
Yep.
Wait, where's that?
Stat, edit. And you can then put all of the numbers, all the data, into that L1. If your L1 has stuff in it, a reminder, if you don't remember how to get rid of it, move your cursor up to the top of L1, hit clear, not delete, but clear, and then the down arrow. That'll get rid of everything that was there. So, I've punched in all the numbers here. And you'll notice that when we get to the bottom, after we type in the last number, you'll see that after the last number, it says L1 11. So the next one we would be typing in would be the 11th number. Since we were told that there are 10 students, then that would make sense. The next one would be the 11. Just a way of kind of checking to make sure that you have everything right, that you didn't double up a number, you didn't skip a number, something like that. All right? So everything's entered, so let's quit out of that. And now we can go stat, and then slide over to calc. And you might remember this, we did this a little earlier in the year, but we did stuff like linear regression and things like that. And we're going to do quadratic regression and cubic regression later on. Do you remember that thing that you saw on the calendar that talked about regression project? That's where that's going to be. It's actually not going to be hard, it's just stuff to do. But anyway, for now, we want one variable stats. So if I hit one variable stats, I get this screen, which should be about the same that you get. And just enter through this, and it has this big list of numbers.
Schmancy.
And so this will tell you everything you need to know. It'll give you the mean, it'll give you the median, it won't give you the mode. It'll give you the standard deviation. It'll give you a few other things too. So when we look at this, we say, Mr. Calculator, please tell us what we need to know about this. And so here's what we find. This top number has an X with a bar over it. You'll never guess what we call this. X bar. Math people are nothing if not, what's the word I want? Creative, thank you. X bar means the mean. So the mean is 42. The next couple we don't care about. This is just the sum of all the x's. So when we added up all of the x's, we got 420. This number down here, n, is the number of numbers there were. So this divided by this should always give us that. Sigma x divided by n should always give us x bar. The third one doesn't really matter. That would be the sum of the x squared, so we don't care. Sx is the sample standard deviation. This, by the way, is a small sigma. This is a capital sigma. This is a small sigma. Sigma x is the population standard deviation. This is what we're going to be using for a while. Okay? Sigma x is the one that we're going to be using for our standard deviation. So our standard deviation here is 8.32. 8.32. So when we come over to our sheet here, and we ask for the mean, so we will put 42, and a standard deviation of 8.32. They then ask us to interpret their meaning in the context of the problem. Help me out here. So in that group of 10 studied for an average of 42 minutes. With an average deviation from the mean of 8.32 minutes is the average deviation from the mean. questions there? Beep. Turn the page.
It's January 7th of 2015. 12:20 a.m.
I would call this a bar graph. They call it a histogram.
It is.
Don't really
Yes.
care. It's the same thing.
12:20 p.m. 2:42 p.m.
Shows the distribution of battery life in hours for a sample of 40 batteries of the same brand. Would you describe this distribution as approximately symmetric or skewed? See, this is good because this is like a real life thing. They don't give you like a perfect thing and say, you know, what is this? Because that's obvious. But here you can look at it and go, makes you think a little bit. So what I would do here is I would draw a curve. Does that pretty much take care of the data?
Yeah.
That curve's okay? Would you consider the curve that I drew approximately symmetric or skewed? I would call it approximately symmetric. I did not do a very good job drawing that. I kind of did this.
We're supposed to do the edges.
When you see skewed, you're going to know it's skewed. Okay? This one's pretty symmetric. The majority of the data is in the middle. Okay? Then it works its way down from there. Yeah, there are going to be some little glitches there. Nothing here, and there's something here and here. But for the most part, it's pretty symmetric. So how would you explain that when it says explain your answer?
The majority of the data is in the middle of the graph.
The majority of the data is in the middle of the graph. Goes down on the outsides from there. That sounds good to me. Your explanations are going to be important. So make sure that you are focusing on them too as you're going through. Would you consider the mean, would you guess that the mean of this set of data, the mean of the battery life distribution, is closer to 95, 105, or 115?
115, 105. Oh wait, 105. Why did I say that?
When we
No,
drew
wait. The mean?
the mean,